Today we are going to discuss about the current electricity. We are going to discuss about the current electricity. What is the first topic? The first topic is electric current. What is electric current? Electric current means rate of flow of electric surges. But we know that there are two types of surges. Positive surge as well as negative surge. Yes or no? So we must know due to flow of which surges we get the current. Since in a conductor, it is said that in a conductor electrons are free. So electric current means rate of flow of free electrons. But what is the free electron? What is the concept of free electron? We must know this properly. Okay? We must know what is the concept of free electron. We know that in an atom, nucleus is there. Around the nucleus, electrons are revolving. These circular orbits are called the energy levels. They possess a definite value of energy. Here, the distribution of electrons in different circular orbits is not according to the rule of chemistry. Okay? So I have simply given a distribution of free electrons around the nucleus. It is not according to any rule. Okay? So they have the definite amount of energy. So this circular orbit having definite energy level, definite energy is called the energy level. So here I draw the energy level of hydrogen atoms. This is the ground state, minus 13.6, minus 3.4, minus 1.51. But we know that in hydrogen there is only one electron. That means the single electron is in the most innermost orbit of hydrogen atom, or it is in the ground state of the hydrogen atom. That means in hydrogen atoms there are some vacant energy level. Okay? Now when we return back to the solid, then what happens? In solid, atoms are very close to each other. As a result, the outermost energy level of each atom overlap each other in the solid. In solid, atoms are very close to each other. As a result, outermost energy level of each atom overlap in this situation. There is a possibility of overlapping. But in two different atoms, there is no chance of overlapping because there is no chemical bonding between them. So here you see, these two energy levels overlap each other. As a result, electrons remain in this energy level, are free to move from this atom to this atom through this point of overlapping. These electrons also free to move from here to here. These electrons also free to move from here to here. Yes or no? So therefore, these electrons, the electrons in the overlap energy level are free. But this electron is not free. It is bound to move in this energy level. Okay? But if some energy is supplied from here to this electron, then it can make a jump from here to here, provided this gap is, this energy, the required energy is very small. Okay? Now when this electron jump from here to here, when this electron reach this particular overlapping energy level, now this electron also can move from this atom to this atom through this point. Is it clear? Is it clear? Is it clear? Now that means whenever electrons are in the overlap energy level, they are called the free electrons. Free electron does not mean that the electrons are free inside the solid and they come outside the solid automatically. They cannot leave the solid automatically. They are inside the solid. They are free. It implies that they can move from one end to the other end of the solid. But in solid, there are some electrons which are not free. They are bound to move around the nucleus of the respective atoms. Since in solid, there are two types of electrons. So therefore, in solid, there are two types of energy band. In atoms energy level, in solid it is band. Actually, energy band is composed of very large number of energy levels. Actually, whenever the atoms comes together to form the solid, there is an interaction between these atoms, and because of these interactions, these energy levels interact each other and they form the energy band. So there are two types of energy band. One is called conduction band and one is called valence band. Whenever electrons are in the overlapping energy level, they are said to in the conduction band of the solid. Because these electrons are free to move from this atom to this atom. Therefore, these electrons are in the conduction band. They can easily move, so they can easily conduct. But this electron, they are bound to move around the nucleus. They are not free, so they are said to in the valence band of the solid. In between these two bands, there is an energy gap. This gap is called forbidden gap. You just see, here also there is an energy gap, here also there is an energy gap, here also there is an energy gap. So this gap is called forbidden gap. Okay? Is it clear? Is it clear the concept of free electron? Now, we know that all the solid can be divided into three classes: conductor, insulator, and semiconductor. What is insulator? Insulator are those solid through which electricity and heat cannot conduct. And conductors, through conductors, heat and current can easily conduct. Yes or no? So in insulator, what happens? The conduction band is completely empty and valence band is completely filled up. This gap between conduction band and valence band is very large. It is of the order of 6 to 7 electron volt. According to NCERT book, they have given more than 3 electron volt are the insulator. That means the solid which form the insulator, they have overlap energy levels. But in these overlap energy levels, there are no electrons. That means the solid which form the insulator, they have overlap energy level without any electron. Therefore, their conduction band is completely empty. That means these energy levels, the overlap energy levels, in overlap energy levels, there is no electron. That means in overlap energy levels, electrons are absent. Therefore, conduction band is completely empty and valence band is completely filled up. And this energy gap is practically very large. It is of the order of 6 to 7 electron volt. Therefore, practically it is not possible to make a jump for this free electron to move from here to here. Therefore, they conduct current. That means insulators are those substances which do not possess free electrons. Is it okay? Insulators also has electrons, but these electrons are bound to move around the nucleus of the respective atom. They are not free. That means all these electrons are in the valence band. Therefore, there is no electron in the conduction band, hence conductivity is not possible. Conduction is not possible in insulator. But in case of the conductors, this gap is practically zero. In some metals, in some conductors, this conduction band and valence band overlap each other. That means a large number of electrons are therefore free. A large number of electrons are in the conduction band. A large number of electrons are in the conduction band, and conduction is easy. That means electrons can move easily from one end to the other end of the conductor. From one end to the other end of the conductor. That means for the solids which form the conductors, this gap is practically zero. Therefore, large number, all these electrons make the jump from here to here. As a result, large number of electrons are in the overlapping energy levels. Since they are in the overlapping energy levels, they are free to move from this end to that end. Therefore, a large number of electrons are in the conduction band and conductivity is possible. So this is the concept of free electron. Free electron does not imply that the electron can easily come out of the metal. They cannot come out of the metal. They only move from one end to the other end. Achha, question, who do I want to ask a question? Have you seen the electron? No. So it is a concept. Similarly, free electron is also a concept. So this is a physical visualization of the free electron. During the discussion of electronics, we mainly discussed how the energy band is formed in solid. আমি ইলেক্ট্ৰনিক্সৰ ডিছকাশ্যনৰ সময়ত ইলেক্ট্ৰনিক চেপ্টাৰটোৰ ডিছকাশ্যনৰ সময়ত আমি এনাৰ্জি বেণ্ডৰ বিষয়ে ভালকৈ পঢ়িম. অ'কে? ইজ ইট অ'কে? নাও we return back to the current electricity. What is current? Current means the flow of charges. In a conductor, electrons are free. Therefore, electric current means the flow of free electrons. So, I can be written as dq by dt. Etuk instantaneous current বুলি কয় বা মই কাৰেণ্টক এনেকৈও লিখিব পাৰোঁ q by t. এটুক মই কি বুলি ক'ম? এটুক মই এভাৰেজ কাৰেণ্ট বুলি ক'ম. চ' এইবিলাক ডেফিনেশ্যন তোমালোকে ক্লাছ 9-10ত পাইছা. সেইকাৰণে ক্লাছ 10ত পাইছা. সেইকাৰণে মই আকৌ নতুনকৈ ৰিপিট কৰিব বিচৰা নাই. চ' হোৱাট ইজ কাৰেণ্ট? We know that current is a scalar quantity. Current, what is SI unit of current? It is called ampere. It is also a fundamental quantity. Can you remember the fundamental quantity? There are 7 fundamental quantities: mass, length, time. Can you remember it? Electric current, temperature, amount of substance, and luminous intensity. So, current is also a fundamental quantity. Electric charge is not fundamental quantity. So, what is dimension of electric current? Dimension of electric current means it is simply A1. Dimension of electric current is A1. But what is dimension of charge? It is A1T1. We cannot write dimension of charge is Q1 because charge is not fundamental. But we can write dimension of current A1 because current is fundamental. Okay? What is the SI unit? It is 1 ampere by 1 ampere means 1 coulomb by 1 second. এইবিলাক জানা তোমালোকে মই ৰিপিট কৰিব বিচৰা নাই. Okay, inside a conductor electrons are free, so current means the flow of electrons. But there are certain other substances, particularly semiconductor. তোমালোকে কেমিষ্ট্ৰিত পাইছা, এতিয়া ফিজিক্সত অলপ দেৰিকে পাবা. In semiconductor, there are 2 types of charge carriers. One is called electron and one is called hole, HOLE. Hole to positive entity বুলি কয়. Actually, hole is a deficiency of electron. So whenever current flows through a junction of semiconductor, that current is due to flow of both the free electrons, both the electrons as well as free electrons as well as holes. Similarly, in electrolytic solutions, there are two types of charge carriers: positive ions and negative ions, cations and anions. Similarly, in a battery also, so there are two types of charge carriers: positive ions as well as negative ions. So inside the battery as well as inside the electrolytic cell, total current means flow of both the positive ions and negative ions. That means only inside the conductor current means the flow of electrons, because inside electron positive ions are not free. But in semiconductor, in semiconductor we are getting two types of charge carriers, electrons as well as the holes. Or in electrolytic solutions we are getting two types of charge carriers, cations and anions. Is it clear? Is it clear? Then we come back to Ohm's law. এইটো তোমালোকে ক্লাছ 9ত পায় 10ত পায় আহিছা. What is the Ohm's law? At constant temperature, current directly proportional to the potential difference across the two ends of the conductor. Current is directly proportional to the potential difference across the two ends of the conductor. I directly proportional to V, provided temperature and other physical conditions remains constant. So there should be a constant. That constant is capital G. It is called conductance of the conductor. That means if we apply a potential difference across the two ends of the conductor, a current flows from positive end to the negative end of the conductors. Since the current means flow of electrons, actually electrons are moving from negative polarity to the positive polarity. But we conventionally taken direction of current as the flow of positive charge carriers. It is because initially people thought that current is only due to flow of positive charges. The concept of electron is discovered at the beginning of 19th century. Before that, the people studied the current electricity and they thought current means the flow of positive charge carriers. It is actually called the conventional direction of current. Okay? I think it is already discussed during the class 10 physics. So if I draw a graph between I versus V, then it is a straight line, provided a very low current flows through it. But normally we know about the resistance of the conductor, not about the conductance. So what is the relation between them? Conductance is the reciprocal of resistance. Conductance is the reciprocal of resistance. So R is the resistance. So I is V by R. So V is equal to IR. So from here also we can say that V directly proportional to I. So if I draw a graph, V against I, again I get a straight line. But this slope and this slope is different. I think you know about the slope. What is slope? Slope means tan theta. It is perpendicular by base. Yet you just concentrate here. The perpendicular is I, base is V. So in this case, the slope of this graph gives I by V. That means this slope gives us the conductance of the conductor. But in this case, the perpendicular is V and the base is I. So here the slope of this graph gives us the resistance of the conductor. Okay? I think this is already discussed during the class 10. What is the SI unit of resistance? It is ohm. 1 ohm means 1 volt by 1 ampere. This is the symbol. What is the dimension of resistance? What is the dimension of resistance? R is V by I. What is the dimension of V? V means potential difference. M1 L square T to the power minus 3 A to the power minus 1 divided by A1. Okay. So dimension of resistance is this. What is SI unit of conductance? Actually, what is conductance? Conductance is the reciprocal of resistance. So therefore, since the SI unit of resistance is ohm, OHM, and conductance is reciprocal of resistance, so it is written as mho, MHO. They simply reverse the letters, or it is written like this. I think this is already discussed during the study of science or current electricity in class 10. Next, we try to discuss about the resistivity and conductivity. Resistivity and conductivity of a conductor. Experimentally, we know that resistance of a conductor is directly proportional to its length. If the length of the conductor increases, keeping area of cross-section constant, then length increases. If cross-sectional area decreases, keeping length constant, then also resistance increases. Actually, what is resistance? It is opposition to the flow of electrons. It is opposition to the flow of free electrons. Actually, what is called opposition? When these electrons try to move from this atom to this atom, at this point of overlapping, some opposition is there. This electron can move like this, this electron can move like this, because these are the free electrons. They move randomly. They do not obey any chemistry rule of any chemistry. So these electron can move like this, these electron can move like this, therefore there is a chance of collision. Again, there is another concept. I think all of you know that there are three types of motion of atom inside the solid. One is the vibrational mode, one is rotational mode. In vibrational mode, what happens? The atoms vibrate about its mean position. If these atoms oscillate or vibrate, this point of overlapping is also oscillating. This point of overlapping also oscillating. As a result, electron cannot move from this atom to this atom through this point, because this point is oscillating. That means the motion of this electron is restricted from this atom to this atom. Is it okay? So this restricted motion of electron is actually called the resistance of the conductor. That means when current flows means electrons are moving. When the electron moves, lot of difficulties arises. Their motion, the motion of the electron is not so easy. They observe some obstruction, and these are some of the concept of obstruction. Okay, these are some of the concept of obstruction. That means one is this electron and this electron may collide here, or due to vibrational motion of these atoms, this point of contact may oscillating. So that is also these electrons will take certain time to move from this atom to this atom. So since the electron takes some time, that means its motion is restricted. So a opposition is offered to the flow of electron. That is called a resistance of the conductor. That is called the resistance of the conductor. Okay, so when cross-sectional area decreases, that means motion of electron is restricted. So its resistance increases. So if I combine these two, R proportional to L by A, so R is equal to rho L by A. This rho is called resistivity of the conductor. This rho is called resistivity of the conductor. It is the property of material of the conductor provided temperature remains constant. That means two copper wire of different dimension may have different resistances, but they have same value of resistivity. Two different copper conductors may have different value of resistances if their dimensions are different, but they have same value of resistivity. Is it clear? So what is rho? Rho is equal to RA by L. So if L is 1, A is 1, rho is equal to R. That means resistivity is the resistance of a conductor. Resistivity is the resistance of the material of the wire having length unity and unit cross-sectional area. What is SI unit? What is SI unit? Rho is equal to ohm, area meter square, length meter, therefore it is ohm meter. So what is the dimension? With the dimension of resistance, length is written. So m1 L cube T to the power minus 3 A to the power minus 1. Now what is conductivity? It is a reciprocal of resistivity. It is a reciprocal of the resistivity. So therefore, reciprocal of resistivity is conductivity. Its symbol is sigma. Have you seen it? Its symbol is sigma. That means sigma is equal to 1 by rho. So 1 by ohm meter. That means mho meter. So this is the dimension of conductivity. Okay. We know that electric current is a scalar quantity. Therefore, here we try to discuss a vector quantity called current density. Electric current is scalar, but current density is vector quantity. What is current density? It is defined as the amount of current passing through a unit area, passing normally through a unit area when the area is held normal to the direction of flow of current. I think during the discussion of electric flux, electrostatic flux, we make area vector quantity by drawing a normal to the area. Can you remember it? Therefore, what is current density? It is the current that passes normally through unit area. So, current density is a vector quantity and direction is along the outward normal to the area, provided area has unit value. So, current density, J, current by area, so its SI unit is ampere per meter square. Now, we are going to discuss about the vector form of Ohm's law. What is Ohm's law? V is equal to IR. So, I divide the equation by L. So, V by L, I by R is rho L, these L get cancelled. I divide this equation by L. L is the length of the conductor. What is R? Rho L by A. Rho is the resistivity. These L and these L get cancelled. So, therefore, what we get? We get V by L is equal to rho I by A. What is V by L? It is electric field intensity, because electric field is negative gradient of potential difference. Okay, V by L is E. So therefore E. What is I by A? I by A is current density. So this is the SI unit of this is the vector form of the Ohm's law. So if I take the J on the left hand side, J is equal to 1 by rho E. 1 by rho is sigma. Sigma is called conductivity. Sigma is called conductivity of the material. So J is equal to sigma E. So this is also another form of Ohm's, another vector form of Ohm's law. Sigma is 1 by rho, conductivity of the material. It is the vector form of the Ohm's law, either this or this. Now, next topic is a resistor. Actually, what is called resistor? We know that every material offers certain amount of resistance to the flow of current. আমি জানো সকলো মেটেৰিয়েলে certain amount of resistance flow of current offer কৰে. But during certain physical experiment or experiment in physics or in our daily life, we require a certain definite amount of resistance. Therefore, mechanically we make certain arrangement, and this arrangement offer certain definite amount of resistance to the flow of current, and these mechanical arrangement are called the resistors. So there are basically two type of resistors. One is called the wire bound resistor and one is called the carbon resistor. এইটো resistor তোমালোকে physics labত দেখিছা, কিছুমান বাটিৰ দৰে কিছুমান তোমাৰ cylinder কিছুমান থাকে, on the body of the cylinder some value of resistances are given. তোমালোকে you can see some cylinder made of plastic or ebonite, and inside that cylinder some coils are there like this, and depending on the length of this coil and cross sectional area, certain amount of resistance is offered here. So this is called a wire bound resistor. One of the basic disadvantage of this resistor is that its size is high. So if you measure the dimension of this type of resistors in the lab, you can see these are the 2 or sometimes 5 or 6 centimeter also, or 2 and 3 centimeters also. So there is another resistor called the carbon resistor. So this carbon resistor is made from the carbon granules, carbon or gurar pora, from the powdered carbon. These carbon resistors are made. These carbon resistors are made from the carbon granules or powdered carbon. What is the advantage of carbon resistor? Their sizes are very small and their cost is very low. But since their sizes are very small, it is very hard to represent the value of resistance on the body of the carbon resistor. The value of resistance of carbon resistor is represented by a combination of 4 colors. It is called the color code of carbon resistor. During the next class, we discussed about the carbon resistors and how the value of resistance can be obtained from the different colors. But what is the advantage of this carbon resistor? Since its size is very small, they can be used very easily in our electronic equipment. আমাৰ ঘৰত যিবিলাক ৰেডিঅ', মোবাইল বা ফ্ৰিজ আছে, এইবিলাকত খুব